All science fiction movies are deceiving you. Interstellar travel, galaxy roaming, it's all nonsense. The truth is, humans will never leave the Milky Way. Not in 10,000 years, not in 1,000,000 years, never. Why? Because the universe has placed a cage around every civilization, locked with 3 keys: the speed of light limit, energy conservation, and time dilation. These 3 locks, any one of them is a death sentence. Currently, the fastest human probe has flown for 47 years and only traveled 24 billion kilometers. Sounds far, right? But it would take 1,600,000,000 years to fly out of the Milky Way. By then, Earth would no longer exist. This is the universe's cruelest design. It lets you see the infinite stars but never allows you to get close. But here's the question. Why exactly these 3 locks? Why is the universe designed to be so hopeless? Let's start with the first lock, the speed of light limit. In 1905, when Einstein proposed the theory of special relativity, the entire physics community was shocked. Not because the formulas were complex, but because it revealed a harsh truth. The speed of light is the ultimate speed limit of the universe. 299,792 kilometers per second sounds fast, but for leaving the solar system, this speed is as slow as a snail crawling up a wall. Even more terrifying is that this is not a technical issue. It is a law of physics. When you try to accelerate an object with mass, you will notice a strange phenomenon. The faster the speed, the greater the mass of the object. As it approaches the speed of light, the mass of a screw will approach infinity. To continue accelerating, you would need the energy of the entire universe. It's like someone telling you that you can run, but your shoes will get heavier and heavier, eventually becoming so heavy that the earth cannot support them. This is not a challenge, it is a curse. The second lock is even more absolute, the conservation of energy. Suppose we really build a spaceship that could approach the speed of light. How much fuel would it need? The answer will leave you in despair. According to the equation E equals mc squared, to accelerate 1 kilogram of matter to 90% of the speed of light, the energy required is equivalent to detonating 2,000 Hiroshima atomic bombs, and a manned spacecraft would weigh at least 100 tons. What does this mean? You would need to convert the entire mass of Jupiter into pure energy just to barely start this journey. Jupiter is a gas giant with a mass 318 times that of Earth. Even more despairing is that this is just for acceleration. You also need to carry the same amount of fuel to decelerate, otherwise you would crash into the target galaxy at near light speed, instantly turning into a plasma fireball, so the actual energy required would need to be doubled.
Some people say, can't we use nuclear fusion?
The sun relies on nuclear fusion to emit light and heat, and theoretically it's feasible, but efficiency is a critical issue. The most optimistic energy conversion efficiency of nuclear fusion is only 0.7%, which means you would need to burn 1,400 Jupiters to complete a round trip. The Milky Way only has 8 gas giant planets in total, so where would you find 1,400 Jupiters? Third, the most insidious lock is time dilation. This is the most counterintuitive prediction in relativity. Suppose you really boarded a spaceship traveling close to the speed of light, flying from Earth to Proxima Centauri 4 light years away. For you, this journey might only take 2 years. You return to Earth excitedly, only to find that 10 years have passed. Your children have grown up, your parents have aged, times have changed, and everything you knew has changed. You have become a stranger from the past. The farther the distance, the more brutal this separation becomes. Flying to the center of the galaxy 26,000 light years away might take only 20 years for you, but 50,000 years would have passed on Earth. Your civilization, your language, all your memories would have become subjects of study for archaeologists. This is not a journey, it is a one-way exile through time. You can never return to the era you departed from. But the most ironic thing is, even if we accept the existence of these 3 locks, the solar system itself is already a huge prison. How big is the solar system? Textbooks tell you that the orbital radius of Neptune is 4.5 billion kilometers, but this is just the range of the 8 major planets. The true boundary of the solar system is the Oort cloud, a spherical cloud composed of 1 trillion frozen comets, with a radius reaching 1 light year. 1 light year is 9.46 trillion kilometers. Voyager 1 has traveled at a speed of 17 kilometers per second for 47 years, covering only 24 billion kilometers. At this speed, it would take 18,000 years to cross the Oort cloud. What does 18,000 years mean? But even at this speed, it would still take 4,300 years to traverse the solar system. More cruelly, these speeds are achieved through gravitational slingshots. The spacecraft uses planetary gravity to accelerate, and once it leaves the solar system, there are no planets to assist it anymore. Your speed is forever fixed at this number, becoming a wandering bullet in the universe that never stops, never slows down, and never reaches its destination. What if we don't rely on rockets and use other methods? In 2016, Stephen Hawking and Yuri Milner proposed the Breakthrough Starshot project, using laser propulsion for miniature probes to accelerate to 20% of the speed of light and travel to Proxima Centauri. Sounds cool. Let's do the math. This plan requires building a 100,000 square meter laser array with a launch power of 100 gigawatts, equivalent to the entire power generation of China. In order to propel a probe weighing only 1 gram, less than the weight of a credit card, and this is just a one-way ticket. After the probe reaches Proxima Centauri, it has no fuel to decelerate and can only pass through the galaxy at 20% of the speed of light, disappearing into the darkness before it can take a few photos, let alone send back signals, which would require additional transmitters. But a weight of 1 gram cannot even fit a mobile phone chip. So essentially, this plan is about burning up a national-level power grid just to launch a piece of metal debris into space that will never return. Some say, what about manned missions? Humans could hibernate for thousands of years and wake up just in time to reach the destination. It sounds very sci-fi, but medical research has provided a harsh answer. The biggest enemy of cryonics is not the temperature, but ice crystals. When cells freeze, water forms ice crystals that pierce cell membranes and tear DNA. Even with antifreeze, only some organs can be protected. The brain's hundreds of billions of neurons. Each connection stores your memories, personality, everything about you. Once ice crystals destroy these connections, you will no longer be yourself when you wake up. Even if perfectly frozen, what about radiation? The interstellar space outside the solar system is filled with cosmic rays. High-energy particles bombard everything at nearly the speed of light. On Earth, we have the atmosphere and magnetic field for protection. In deep space, this radiation will gradually destroy your DNA, induce cancer, and damage the nervous system. After flying for thousands of years, your body will slowly decay into a pile of mutated cells in the hibernation chamber. What about a generational spaceship? Build a huge immigrant ship where several generations are born, live and die on board until reaching a new home. This is a favorite setting in science fiction novels, but reality is much harsher than fiction. First is the scale. A spaceship capable of maintaining an ecosystem needs at least 500 people to ensure genetic diversity. Each person needs 2 kilograms of food, 2 liters of water, and 20 cubic meters of air circulation per day. For a 10,000-year journey, it would require 36,500,000 tons of supplies, not including equipment wear and tear, medical devices, and entertainment facilities. The total mass of the spaceship would reach over 100 million tons, 10,000 times heavier than the largest aircraft carrier in history. The energy needed to propel it falls back into that dead loop. Burn hundreds of Jupiters? Even more fatal is human nature. What happens when generations live for thousands of years in an enclosed space? History has given us the answer. A closed society inevitably leads to totalitarianism, superstition, and collapse. The first generation might still remember the mission. The third generation will question why we are flying towards a planet we have never seen. The 10th generation will consider Earth a myth, and the 100th generation will completely forget science, reverting to primitive tribes. Eventually, this spaceship would become a drifting tomb, carrying a group of descendants who have lost their purpose, memory, and civilization, wandering forever in the darkness. What about wormholes? The shortcuts through space in science fiction films, reaching anywhere in the universe in a second. Theoretically, general relativity does allow for the existence of wormholes, but to open a stable wormhole, negative energy matter is needed. What is negative energy? Imagine a substance with negative mass, which is not attracted by gravity but repels everything. This substance would reverse gravity and tear open a hole in space. The question is, does this thing exist? For 70 years, no experiment has observed a trace of negative energy matter. It seems more like a symbol in a mathematical equation rather than something that truly exists. Even if it does exist, how much would be needed? Calculations show that maintaining a 1-meter wide wormhole requires negative energy equivalent to the mass of an entire galaxy. A galaxy, that is the mass of 200 billion suns, and it has to be negative. So wormholes are essentially the universe mocking us. It gives you a door, but hides the key in a non-existent dimension. Every escape route is welded shut by the laws of physics, and every theoretical loophole requires a god-level civilization to exploit. But we cannot even leave the solar system. However, the most despairing thing is not the technology, but that the universe itself is abandoning us. In 1998, two groups of astronomers simultaneously discovered an astonishing fact: the expansion of the universe is accelerating. This discovery shocked the world because, according to common sense, gravity should slow down the expansion. However, observational data shows that distant galaxies are moving away from us faster and faster. Dominating all this is dark energy, a mysterious force we do not understand at all, which accounts for 68% of the total energy of the universe. It acts like an invisible hand, pushing all galaxies farther and farther away. What does this mean? The galaxies you can see today may disappear from view forever in 10 billion years. The universe is actively severing our connections with other civilizations. Even if extraterrestrial civilizations exist, we will never be able to meet, because the expanding universe will isolate us on our own islands forever. This is the ultimate cage. Not technology, not distance, but the structure of the universe itself. So perhaps the answer to the Fermi paradox is this. It's not that there are no extraterrestrial civilizations, but that all civilizations are forever confined to their own galaxies by the laws of physics. The Milky Way may have billions of civilizations, but we will never meet. We are like prisoners locked in different cells, able to hear each other's voices but never able to shake hands. But is this really a tragedy? From another perspective, the Milky Way itself is a vast kingdom with 400 billion stars. Even if you explore one per second, it would take 12,000 years. Here, there are scorching blue giants, ancient red dwarfs, mysterious neutron stars, terrifying black holes, rocky planets, gas giants, diamond planets, and rogue planets. The richness of this kingdom far exceeds all human imagination. Being trapped here may not be a curse, but a blessing. It makes us stop chasing the illusion of conquest and instead focus on managing this unique home. It teaches us humility and also gives us responsibility. If intelligent life is so rare in the universe, then we might be the only eyes and brain of the entire Milky Way, the only vessel for the universe to appreciate its own magnificence. So, when you look up at this starry sky, do not see it as a cage that imprisons you. See it as an infinite legacy waiting for us to explore. We can never leave the Milky Way, not because of failure, but because we inherently belong here.